Okay, welcome back. This is Chapter 8. Chapter 8 is all about routing. So, as always, we'll start with the learning objectives for this particular chapter. Talks about how routing is different from switching. Yeah. What autonomous systems are. And by the way, I hate that abbreviation AS because it sounds like you're saying ass. What routing tables are. How to view routes to a network. Two categories of routing protocols, and thankfully we're not going to go into a lot of detail on routing protocols, and what route aggregation is and why that's useful. Okay, so let's just start, as always, at the beginning. So what is routing? Well, routing basically has two real honest-to-God meanings. If you were to drill down and be as particular and specific as possible, routing is determining the path that a packet is going to travel. It is not the actual putting the packet on the wire and sending it. Routing is looking at the map and figuring out how to get from here to California. It is not jumping in your car and driving. So routing is mapping. It's how to figure out how to get from point A to point B. Forwarding is the part where you actually jump in the car and you take off. So routing and forwarding are kind of a cool little combination. So routers, the device called a router, perform both those functions. They do routing because they know how to get from point A to point B. Plus, they also forward things from one place to another. Okay, so next thing we're going to talk about basically on page 269 is the difference between the old style like an Ethernet, an L2 Ethernet scenario. Like I have just an Ethernet segment, and there was some switching going on. I had an L2 switch, and so something would come in, it would look at the MAC address and figure out what MAC address needed to be, and it would just forward it back and forth. So that type of thing works pretty good. The only real problem there is that the layer 2 type of switching was really designed to be working inside a local area network, not things coming in from the outside or things leaving from the inside out. So in other words, a single Ethernet segment, you're cool. If you have a single Ethernet segment that's not connected to anything, you don't need a router at all. You could just do with bridges and switches and everything would be fine. You wouldn't be able to talk to the internet or anything like that, but you could still do file sharing and printing and instant messaging back and forth between the PCs. I mean, there are secure environments where that's the norm, where all the machines inside the LAN can talk to each other, but nobody has access to the internet. Okay, you don't need a router in that case. Okay, so we already know how to send a frame from an L2 to another L2, right? The bridging and the learning bridge and, the switches and all the rest of that stuff. So that's kind of Chapter 3 stuff. And now we're talking about how do I get something from a network over here, an L2 network over here, to an L2 network over here. That is what this chapter is all about. It's about connecting two disparate networks together. Okay, so a router, the device, is the thing that does the connection. So in order for this to work, there actually has to be a device that has 1 foot in this world and 1 foot in this world. And it's the one that can talk back and forth between the two worlds. That's how it works. There's a figure here that talks about this is the old style switch. So this is a single L2 segment. It's a switch. Sure, packets can go here and there's some sort of a decision made on where to send it. Let's say it's actually going over here. So it comes from here, a decision is made, and then it goes to here. Got it. Now, each one of these little blue tubes is one of these things. So I have a network over here and a network over here and a network over here. So essentially I've got 6 networks going and I've got 3 or 4 routers that connect between these two things. So right off the bat, in a typical Ethernet segment, there isn't really more than one path. You could have a loop, but the loop was really designed for redundancy. The loop was never intended so that one packet would go this way and the other packet would go that way. It was never like I have a choice on how to get to a single destination has more than one choice. It's either you're using this link and if this link goes down, well then I'll switch over to the other. So it was like, a standby connection. Not the case here in routers. The router basically says, well, there's two ways you can get from this machine to this machine. I could go router 1, 2, and 4, or I could do 1, 3, 2, and 4. So there's some decisions, and these aren't backup links. These are honest to God real live links that connects this LAN over here to this LAN over here. So that link in the middle is not like sitting around waiting for something to die. Okay. So that's the whole concept of routing. Routing is not radically different. The goal of L2 switching and L3 routing is the same. The goal is, hey, I got a packet over here and I want it to go over here. Okay, so the goal is the same. But the things are different. One is, these are disparate networks that are not related to each other in any way, or it's very possible. Routers have more choices because there's probably more than one path, unlike over here. And so there's lots of little difference. Okay. So, one more time, Chapter 3 stuff, forwarding based on their MAC address. So the MAC address is what made the decision on passing things back and forth. Over here, it's the IP address that makes the decision. This router gets a thing and says, hey, I've got something I need to forward. Let me look at the MAC address. Let me look at the IP address, look at my routing table, figure out where to send it, because I need to send it to 2 or 3. And then I'll figure that out, and then I'll push it out on the wire. Okay. So it should be fairly obvious, looking at this diagram, that one of the things that routers should do is attempt to figure out the most optimal path. I mean, yes, I could send a packet from 2 to 3 to 4, and then on. I could. Or I could send it to 1 to 3, 2, and 4. Now, it should be fairly obvious that sending it through this extra link is probably not efficient. So one of the rules of routers is to find the shortest path through the network, and they use this term. It's called cost, and the lowest cost, and they do not mean money. Okay, they mean cost is just an arbitrary term they use to describe how things are set up. For example, let's say that this is a 100 megabit line and this is a 10 megabit line. So you want to prefer using the higher speed, so it would have a lower cost, and so that whichever one has the lowest cost is the one that's going to be primarily used. Okay, that's basically how that part works. So more decisions, and they're based upon the best or lowest cost. On page 272, they talk about routers and networks, and so there's yet another little thing. So I mentioned that these guys have one foot in one world. Here's a network over here, and this is the network that's a 131.247.0.0. And then over here's another one who's not even related, not the same company, not the same place, not the same building, completely different, and it's 65.32.0.0. So this router has to have two interfaces. One interface has an IP address given by this guy, and then it has to have another interface over here given by this guy. So the IP addresses that are assigned, the router, it has to live in both worlds. It has to have an IP address that's valid over here and an IP address that's valid over here. So that's basically how these things work. It has one foot in each world, and it is the only way that you can pass documents back and forth or packets back and forth, because it's the only one that has an IP address in both worlds. That's required. I mean, if you don't have an IP address in both worlds, you're not going to be able to talk between the two. So it's kind of sort of simple. Now, this port, imagine this thing as a physical device. This port is going to have a MAC address on this side and a MAC address on this side. They're not going to be the same MAC addresses because we're not sending it out through the same port. So a port over here has a MAC address and an IP. The port over here has a MAC address and an IP, and both of the MAC addresses are different, and both of the IP addresses are different. Cool. Let's look at the part of the reason why this is a little confusing to a lot of people is that that's not normally the way your home network. Your home network is typically a lot simpler. Inside this thing, right, that you call a router, it has a wireless access point, it has a switch, it probably has more things than that. and then it has this router thing. So, but you don't see any of those discrete components. All you see is like a box. Well, let's see. Well, I got a WAN port and some LAN ports. So the WAN port is the thing coming from your internet service provider. So whatever your internet service provider, you jack into that one. Dink. And then all your machines you tie into here. So the routing actually takes place between this port over here and these 4 ports here. That's where the routing takes place. So your machine is a router. So this has a MAC address that's not yours. This has a MAC address of your internet service provider. This has the MAC addresses that belong to you inside your network. Okay. So the MAC addresses are different and the IP address ranges are different. Now, in this particular case, the IP address range of all 4 of these are going to be related. It'll be like, 192.168.0.1, 2, 3, 4, right? So a whole group of those IP addresses. And over here, you're going to have, 75.72 point whatever. Okay. So again, the routing actually takes place just between these 2 points. All right. The next thing we need to talk about is how the big boys. So this is the small end router that you probably have at home, okay? And there's 2 different classes of routing that takes place. Let's say I'm a company, relatively big company. I have to have some routers. I'm pretty decent size, and so I'm connecting. I have like 2 routers, and then my 2 routers talk to the outside world. But my 2 internal routers are not designed for me to go to the internet. That's not what they're for. These are my internal routers that I use just inside my buildings to get route packets from building A to building B. That's it. Okay, that's all they do. They're not routing packets to some other off-world destination, so to speak. Okay. In those scenarios, I'm in control of all those routers. So that's what's called an autonomous system. An autonomous system means a group of routers for which they are under the control of a single entity. So I'm Bob's Plumbing and I have 2 routers. I'm an autonomous system because I have 2 routers that belong to me, and autonomous means I get to pick how they're set up. I get to pick what the cost is between the routing decisions. I can say, well, I want to make this a 5. I want to make this a cost of 10, so it'll favor this particular link versus that one. I don't have to go talk to anybody or ask anybody. This is my network. I can do anything I damn well please. It's autonomous, an autonomous system. Okay, now that's the small scale. Now let's scale that up a tiny bit more. Let's talk about Time Warner. Now Time Warner probably has, thousands of routers scattered all over the U.S. And they are an autonomous system. They control all their routers, and they control the rules that are used to route packets between the 2 routers, or the thousands of routers. And they're not obligated to tell me anything about them. Just like I'm not obligated to tell them how my 2 routers are configured, they're not obligated to tell me how their 1,000 routers are configured. Okay, an autonomous system. Got it? Okay, let's continue. By the way, itty bitty folks, like your home router and the scenario I just described where you may have 2 routers but not on the edge, those kind of scenarios, that's called a stub autonomous system. And a lot of people don't. Technically, it is an autonomous system. It meets the definition, but that's not normally what people mean when they say autonomous system. When they say autonomous system, they're really talking about the backbone people, the Time Warner, the Sprint, Comcast, those guys. That's what they're talking about. They're not talking about mom and pop. Although mom and pop meets the definition, when they talk autonomous system, they're talking big business, thousands of routers. Okay, probably this is a good place to stop for the 15-minute mark. Let's just pick this thing up again in just a few.